Hello, everyone. Welcome to our Analytical Chemistry vodcast. Today, we'll be discussing how glucose levels are monitored during fermentation of oil palm empty fruit bunches, or EFP, into bioethanol in a Malaysian biorefinery, and answering the question, are classical methods still relevant in bioprocessing? But before doing so, I would like to introduce my fellow speakers who will be discussing this topic today. First off, there's myself, Faris. Then, Shahrul will be discussing as well.
Hi everyone.
Then there is Shime,
Hello everyone.
Melissa,
Hello.
Adam,
What's up, guys?
and last but not least, Iji.
Hi.
Everyone that I've listed from Group 11 today will be discussing this topic with me. Malaysia is one of the world's largest palm oil producers, generating a large amount of agricultural waste, such as EFP. Researchers and industries are converting this waste into bioethanol through fermentation. To ensure the fermentation process is efficient, glucose concentration must be monitored regularly. Today, we'll compare a classical analytical method and a modern instrumental method used to measure glucose levels. Melissa, could you start us off?
Let's consider a bioethanol refinery in Malaysia that uses EFB as a feedstock. After pre-treatment and hydrolysis, cellulose from EFB is converted into the glucose. The microorganisms such as yeast will be then ferment the glucose into the ethanol. So throughout the fermentation process, the technicians need to monitor the glucose concentration. If the glucose level remain too high, fermentation may be not complete. Or if the glucose level drop too quickly, it may indicate process issue or nutrient limitations. Therefore, accurate glucose monitoring is very essential for maximizing ethanol productions.
Oh, thanks, Marissa. That's a very good explanation. So there's one traditional method used to determine glucose concentration, which is the Benedict test. Benedict test is a colorimetric chemical analysis. So the sample is mixed with the Benedict's reagent, which contains copper 2 sulfate, sodium carbonate, and also sodium citrate. When the mixture is heated up, reducing sugars such as glucose react with the blue copper 2 ions in it. Then the copper 2 ions are reduced to copper 1 oxide. So it will produce a color change there. The color changes are from blue to green, and then yellow, orange, and lastly, it will end with a brick red color. So what does this mean? The more glucose present in the sample means the more intense the color change.
So, what you're saying is the glucose concentration can be estimated simply by observing the color?
Yes, that's correct, Faris. It's as simple as that. The color provides an indication of glucose concentration. The method is very simple. It's not expensive and requires only basic laboratory equipment and also basic laboratory knowledge. However, the result depends on the visual observation only. That means it may be less accurate compared to modern instrumental techniques that we have nowadays.
Alright. Thank you Adam for your insightful explanation for the classical method. However, in our discussion, there will be also the modern instrumental method, where this method is more advanced method used in biorefineries in HPLC, which is from high performance liquid chromatography. So HPLC can automatically separate, identify, and also quantify the glucose present in the fermentation broth. And in this HPLC analysis, the sample is basically injected into a flowing mobile phase, and then the sample will passes through a chromatographic column. So the different compounds will travel through the column at different rates. So as the glucose will exit the column, a detector will measures its signal and also generates a chromatogram. And then this area under the glucose peak will be directly related to its concentration. And lastly, HPLC will provide highly accurate and also precise measurements, which can analyze multiple compounds simultaneously.
Wow, Shahrul, that sounds much more sophisticated than the color change method.
Okay, yes, both methods have their own advantage and disadvantage. So, Benedict test is very inexpensive and easy to perform. It also requires minimal training and simple laboratory equipments. However, it is relatively slow and provides only approximate results. It may also be affected by human interpretations of color change. On the other hand, HPLC provides rapid, automated, and highly accurate measurements. It also can detect small concentration change that cannot be observed visually. However, HPLC instrument can cost tens or even hundreds of thousand ringgits. It also requires trained personnel for operations, maintenance, and data integration. Therefore, Benedict test is suitable for basic training, while HPLC is preferred for industrial process monitoring and quality control. So that is the comparison of both methods.
Okay, thank you, Shamil, for your explanation about the comparison of method. Now we'll move to the sample preparation. Before any analysis can be performed, the fermentation sample must be first prepared properly. The fermentation rock contain yeast cells, suspended solid lignin residue, and other impurity. First, the sample is collected from the fermenter. Next is centrifuge or filter to remove solid particle and microbial cell. The clear liquid is then collected for the HPLC analysis. The sample may be filtered, diluted, and passes through a membrane filter with a pore size of 0.45 micrometer. This prevents clogging of the chromatography column. Finally, the prepared sample is transferred into sample vial before analysis. The proper sample preparation is important because inaccurate preparation can affect the reliability of the glucose measurement. That's all for me. Thank you.
Thank you for speaking up, Luigi, and I thank everyone here for being able to come up and provide their points with very good reasoning. As for what is next, I will now proceed with the calculation. These are our calculations that we use to solve problems and real-life scenarios regarding metabolites, including from both classical and instrumental methods. The most prevalent calculation being Beer-Lambert's law, which is used in both classical and instrumental methods. And while I have your attention, I am now showing a live demonstration and calculation using both classical and instrumental methods, those being titration and calibration curve, both on the same problem to show the difference in the accuracy and speed of both methods. In conclusion, monitoring glucose levels is essential for controlling the fermentation of oil palm EFB into bioethanol. Classical methods such as Benedict's test provide a simple and low-cost way to estimate glucose concentration. Meanwhile, instrumental methods such as HPLC offer rapid and highly accurate measurements required in industrial applications. Both techniques play important roles depending on the required accuracy, cost, and operational needs. Analytical chemistry continues to support the development of sustainable biofuel production in Malaysia. Thank you for watching our podcast.
Thank you, everyone.
Thank
Thank
you,
you.
guys.
Thank you.
Thank
Thank you.
you.